All right, so long or synthetic division with remainders. Now, I do want to get a read of the room here real quick. How many of you all prefer long division? Raise your hand. Okay, we got 3, 4 long divisioners. How many synthetic divisions? 1, 2, 3 synthetic divisioners? Okay, wow, long division taking this of the not...
We'll say that book party.
But what?
We'll say in the pivot party.
I know there's one services.
So we'll do this problem through long division, but we may also do one through synthetic as well, just to help out everyone. So we have a problem like this. We'll set it up just like usual. The divisor, the denominator of this goes on the outside. I think it is called a dividend. What's up top with my 4th grade memory returning to me, the dividend, or the numerator of the fraction, as I'm much more attuned to calling it, will go inside the division bar here. So we're going to do this like usual. I'll go through the steps, but you guys have done long division for the past week, so this isn't going to be anything new. We need to make x match x cubed. How do we do that? Multiply it by x squared. And then as soon as we put a number up there, what do we do with that number, Keegan? As soon as we put a number up here, what do we do with it?
What's it called? Put it into the x plus 3.
Yeah, we put it in. We distribute it in, right?
Yeah, distribute it.
So we distribute it in. X squared times x makes x cubed. X squared times 3 makes positive 3x squared. We can go ahead and do we add or subtract? Subtract. Long division is always subtract. Synthetic division is always add. So we subtract these. X cubed minus x cubed, we get a 0. That's the same thing. They're going to cancel out. But then we have negative 2 minus 3. We are going to end up with negative 5x squared. These are going to drop down as per usual, minus 14x minus 5. And then we start the process all over again. We ask ourselves, how can we make x match negative 5x squared? Brody, what are we going to multiply it by?
Just it itself, negative 5x squared.
Negative 5x, well, how do we make x negative 5x squared?
Yeah,
Drop it.
Not quite. Close the Chromebook, Brody. Aiden, what do we multiply it by?
Negative 5x.
Negative 5x.
Oh.
So, this goes up here like Keegan said a moment ago. As soon as a number goes above that division bar, it distributes in to our divisor. Negative 5x times x makes exactly what we wanted it to make, negative 5x squared, and negative 5x times 3 makes, negative 15x. I almost made that positive. So the first one's going to be 0, first one's always going to be 0, but then our second one, what is that going to be? Because it looks, what?
1x.
1x, not negative 29x?
No, because you're subtracting a negative, so it means it adds.
Subtracting a negative, those counteract each other, those add. Negative 14 plus 15 makes a positive 1x. Now this does drop and we have minus 5. So this is where things are going to get a little bit unusual. Because traditionally we ask ourselves, how do we make x into this term? And we're still going to ask ourselves that. What do we multiply x by to turn it into this? It already is itself. And it's very easy to answer this question and say, well, we don't multiply it by anything. It's already x, right? But we have to multiply it by something. For us to put something up here, we have to answer the question, what do we multiply it by? So 1, exactly. It's easy to say nothing or 0 or whatever, but it is 1. If you want to keep a number the same, you're going to multiply it by 1. Now again, that 1 distributes into these. Of course, it's going to make the same thing, because anything times 1 is itself. So we're still going to get x plus 3 down here. Now what you'll notice is when we subtract these, yeah, Brody's saying it over here. We're getting a 0, but that's not what we're getting here. Negative 5 minus 3. We're going to get negative 8, right? Every other example has been a 0. So this is our remainder. This is kind of like back in the day whenever you divided your stuff and you had to put a little r and a number out to the side of it, your remainder, right? We are not going to use a little r. I wish we would. That would be a really nice, wonderful life for us to live, but we're not. What we are going to do is we are going to take our answer here, x squared minus 5x plus 1, and we have to attach onto that equation what we were unable to divide out. Effectively, we have this little straggler at the end of the problem that can't quite get fixed, right? It's still trying to be divided. It's eternally going to be trying to be divided. So we take this sign, whatever sign it is, positive or negative, and we write a plus or a minus after our last term. So this is a negative number, we're going to write minus, right? So minus. And then we write the number, not the sign, because we already wrote the sign, but the number, in this case 8, over our divisor, x plus 3. So this kind of notes, this came out perfectly. X squared minus 5x plus 1, that came out perfect. That went well, but we have this straggler, an 8 that's still trying to be divided by x plus 3, but is not working. It cannot happen. It's not going through whatever.
I feel like there's a catch. There's something we have to do after that.
There's nothing we have to do after that. Yeah, Madison says it sounds like that's going to be, we got to do more. We can't have an x plus 3 in the denominator. Math doesn't like us writing it this way, whatever it may be. No, it's perfectly fine. Believe it or not, this is a wonderful way for us to write it. It is the standardized form, or the commonly accepted way. Not a square root, not a fraction inside a denominator, not an imaginary number. None of that. It's good, right? It is great. Now, I want to ask a theoretical question to you guys. Let's say we wanted to make a combined fraction out of this equation. If we wanted every one of these denominators to be x plus 3, we could do that if we multiplied x plus 3 into every term, right? If we made the denominators match. What would that answer look like? Anybody know? You are spot on, Keegan. Keegan, you're getting a point for that. You are spot on. It would be the original equation. Because that's a combined fraction. It's this combined form with x plus 3 underneath the whole thing. That is a good answer. I'm impressed. I wasn't sure anybody was going to get that. So, let's move on to one other question. I'm going to do another one of these through synthetic division so you can see what it looks like. Madison, can you be so kind as to go over to my computer and scroll over? You'll see at the beginning of another question on the screen. Scroll over so I can write that one down.
Wait, can we do one the other way first?
I'm doing one in synthetic division. Yeah, that's this example.
X cubed minus 13x squared plus 40x plus 18 divided by x minus 7.
Alright, so we are going to do this one through synthetic division, our secondary method of doing these problems. So we are going to start our process off by setting up our problem, our weird kind of little way of writing these things. We're going to start with a box, and we have to put a number in that box. Now, what number are we going to put in the box? 7. Where are we getting that 7 from? The denominator. We see there is a negative 7 here. You always remember you flip the sign and you put it in here, right? So that is going to be a positive 7 in that box. Now, what goes outside of the box?
The numbers on the top.
The numbers, not the
Coefficients.
The coefficients, that's the term, right? So what's our first coefficient going to be? 1. Not 13, but negative 13. Got to keep the signs. 40 and 18. We're going to put a plus sign and leave a line. Our very first step is what, Elijah? Very first step in synthetic division. What do we got to do? Drop the 1. Or drop the first term. It's usually going to be 1. A lot of times it's going to be 1. But we drop that first term. So that first term drops. As soon as it hits below that line, what does it do? Bounces up by doing what? What does it have to do to bounce back up? What'd you say? 1 times 7. You multiply by the number in the box. You multiply 1 times 7. Now it's going to bounce back up there as a 7. Negative 13 plus 7 we get?
Negative 6.
Negative 6. Multiplies by the box to bounce back up, and we get?
Negative 42.
It adds? Negative 2. Multiplies and negative 14. Now when these add, we end up with a remainder, and I'm going to write this in a different color, of 4. Now you guys are aware we usually have zeros there. I almost call it our self-check mechanism, right? But that's not what happens when we have remainders. So let's fill in our x's real quick. We took 1x out of the equation, and we started with x to the third, so my first term is going to be what? X squared. So 1x squared minus 6x minus 2, and then
The 4.
this is our 4. It's very easy just to say minus 2 and then, well, plus 4 or something, right? And then make a positive 2, combine those terms. We cannot do that because that last term is almost the absence of an x. It's the absence of this because we keep going down. So we're going to write this, our equation, our answer that came out nicely. X squared minus 6x minus 2. And then, how do you think we finish this?
4
4
over
over x minus 7.
4 over x minus 7. What sign is going to be between the negative 2 and
Positive
this?
plus.
A plus. Where are you getting that plus from?
Because
The
it's
positive
The
4.
positive 4. You're exactly right, Aiden. Good stuff, man. All of you guys who said that. So that would be our answer here. That is going to be the process for us to solve synthetic and long division problems with remainders. Any questions about that?
Nope.
All right, I'm going to cut off the video here. Comment, like, subscribe.